Let a, b, and c be positive and a not equal to 1. The equation, oh my, okay, so this huge equation has a repeated root when one of these conditions is true. Okay. I suspect, looking at this, if we have a combination of logarithms of different base and exponents and all this kind of stuff, I suspect we should just use some rules of logarithms to turn this into probably a quadratic equation. But yeah, let's just try to manipulate this and see where we can get to. Okay. So first, b to the x to the power of x is the same as b to the 2x. I'm going to write this as c over b to the power of x. I mean, b to the 2x and then log base b, that's just 2x. And here, this will be x times the log base a of c over b. Okay, and a repeated root. I mean, this is an equation of a straight line. Unless the coefficient in front of the x is 0. So if I set that coefficient equal to 0, this isn't even possible. Is this possible? This is a to the negative 2 is equal to c over b, which is not at all one of the options we're given. Oh my goodness. Yeah, I made a very silly mistake. Extremely silly. This is, of course, x squared. Oh, yeah, that's kind of embarrassing. Okay, so we have x squared plus x times log base a of c over b plus log base a of 1 over b times log base a of c is equal to 0. Okay, so a repeated root, this is simple now. We just write out the discriminant of this and set it equal to 0. So the discriminant is log base a of c over b squared minus 4 times this quantity, log base a of 1 over b times log base a of c, and this has to equal 0. So we've got log base a c over b squared is equal to 4 log base a of 1 over b log base a of c. And how do I should I raise a to the power of everything? I don't really want to use like laws of logarithms and expand everything. Should I use the process of elimination here and just go through these and see which ones work? I mean, we're taking the square root here. We have to worry about plus or minus. I mean, it's a little awkward to be exponentiating things here. Okay, again, I don't like doing it, but I'm going to use a process of elimination. So option E we can throw out right away, because if A equals B equals C, and A is not equal to 1, so none of the numbers are equal to 1, one of these two things will be negative, and that's not possible. So let's look at option D. C is equal to 1 over B. So this turns into log base A of 1 over B squared is equal to 4 log base A of 1 over B squared. And so this says log base A of 1 over B squared is equal to 2 log base A of 1 over B, which is true. Okay, so that's potentially an option. That's an option. In fact, I think that, I mean, I'm just going to stop there. We found it. That's going to work. Like, how do you manipulate this equation to get that? Yeah, I mean, there's the answer. Again, I did it by checking the options that were given, but like I don't see a convenient way of manipulating this to end up with that. I mean, it would be nice to somehow exponentiate with respect to a to the power of all this stuff, but that just looks weird. Anyway, there we go. Not the cleanest way, and a couple stumbles along through the process, but a good thing I got there. Thanks for watching.